Let's try to repeat the previous example without an actual graph, but just from the equation of the function. So first we're asked, is the point 1 comma 1/2 on the graph of f? We're just going to take the x equals 1, plug it in, and see what we get. So we get 1 over 1 plus 1. 1 plus 1 gives us 2, so we get 1/2. 1/2 is equal to 1/2, so we are good. The answer is yes. That point is on the graph. Let's try it out again with -2, -2. We're going to take this -2 as our x value, plug it in, see what we get. So we end up with -2 over -2 plus 1, which gives us -1. Double negatives cancel out, leaving us with 2 over 1, which gives us 2 if we simplify it down. And 2 is not the same thing as -2. So then, because f of -2 is not equal to -2, this point is not on the graph. Now we want to figure out what x equals 2 is equal to when we plug it into the function. So f of 2 is 2 over 2 plus 1, which gives us 2/3. That's it. Now, let's figure out how to reformat this question. So if f of x is equal to 2, what is x? We can solve that. And then we'll talk about the geometric interpretation of that. So to solve something like this, we'll multiply x plus 1 on both sides just to clear out the denominator, right? I may use that term often. We're just trying to get rid of fractions. Everybody hates fractions, might as well get rid of them. Now that we have no fractions, distribute the 2 and then solve. So you can subtract the 2x over and then multiply or divide by -1, and you get x is equal to -2. All right, that's what we saw up here. Now, this question is really asking, where does y equals 2 and y equals x over x plus 1 intersect? Right, y equals 2, that's going to give us a horizontal line. Y equals x over x plus 1, that's going to give us the graph of this function. Question 4 is essentially asking us to figure out the intersection of those two geometric shapes. We want to figure out the domain of f. Domain is the largest set possible for whatever we can plug in. Since this is a fraction, we can't have 0 in the denominator. So we set up this, I guess, non-equation. It's not an inequality. I guess it might be an inequality, yeah. So we'll just subtract that over, and we get that x is not equal to -1. So in interval notation, we just want to chuck -1 out of there. In set builder, we have x for which x is not equal to -1. Next, we want to find the x-intercepts of the graph. The x-intercept, remember, is when y is equal to 0. So we come over here, we have 0 is equal to x over x plus 1. And just like we did over here, we can multiply both sides by x plus 1. When you do 0 times x plus 1, the 0 absorbs it and just becomes 0. And so x equals 0 is the x-intercept of this function. Over here, we want the y-intercept, which that is when x is equal to 0. We just go ahead and plug in 0. All right, so that gives us 0 over 1. And 0 over any number that's not 0 is equal to 0. If you're interested, 0 over 0 is a really bad combination of numbers that you'll see in calculus next semester. Now, the x-intercept and the y-intercept are actually exactly the same. It is this point 0, 0. which we call this the origin. Right? In case I let that word slip, the origin is just the point 0, 0.